Hello, my name is Shalin Zamora and I'm going to talk about AEC chambers. I will discuss about phototimers versus ionization chambers, minimum response time, backup time, density control adjustments, alignment and positioning considerations, as well as compensating issues and collimation. Automatic exposure control, AEC, is a device used in X-ray exposure termination. The goal of the AEC is to give a reliable X-ray image exposure, whether it's film, CT scan, or digital detector. The AEC system can also mechanically set off elements like X-ray voltage and tube. The purpose of the AEC is to deliver consistent exposure across a wide range of atomical thickness to potentials and users. Detectors used in AEC system include fluorescent screen with photodiodes or photomultiplier tube, ionization chambers, and possibly solid-state detectors. I would like to show you an image of the ionization chamber versus the phototimer. On the left, you can see the ionization chamber. This is filled with air and connected to an exposure switch. When exposed to the X-ray photons, the air in the chamber became ionized, sending an electrical signal to the meter. When the meter receives the amount of radiation, the exposure switch is activated and the radiation ends. The ionization chamber is located on top of the image receptor. The X-ray photons came in contact with the chamber before the image receptor. This makes the ionization chamber an entry-type device. On your right side, you can see the phototimer, who uses fluorescent cold paddles that convert the X-ray photons into light photons. The photomultiplier tube converts the light photons into electrical charge and sends it to the meter. When the sufficient amount is received at the meter, the exposure control automatically stops the excess of radiation. The fluorescent screen and the photomultiplier are positioned behind the image receptor. The X-ray photon exits before are being detected by the chambers. This makes the phototimers an exit-type device system. Also, it's important to mention that in both systems, the electrical charge is always proportionate to the amount of radiation received. The ionization chamber is the most common use because have less chance of failure, but is less sophisticated and less accurate than the phototimer. In projectional radiography, an AEC system can use a single or a few physical thin radiation ionization chambers placed between the patient and the image receptor or cassette. In points where the low energy X-rays are incorporated, the AEC detector is positioned behind the image receptor. In a less complex AC system, ionization signal from the AEC detector is separated from voltage waveform in shape of the ramp. The ramp shape signal goes up into reach the terminated energy. At this point, the X-ray exposure is terminated. Now I would like to talk about photomultitimers. The photomultimer uses a fluorescent screen and a device that transforms the light to electricity. Electronic energy is reached from visible light energy through the electronic device called photomultiplier tube. There is also another device that takes the same role as the photomultiplier tube and is called photodiode. Since the detectors are placed beside the image receptor, phototimers are taken to be the exit type device. The main reason behind the positioning is for radiation to exit the image receptor prior to the measurement of the detectors. Ionization chambers. An ion chamber is an air-contained hollow cell connected to the timer circuit through an electrical wire. Since they are placed in front of the image receptor, the AEC device are taken to be an entrance type device. The reason for the positioning is to facilitate the interaction of the radiation with the detectors prior to the contact of the image receptor. The air in the ionization chamber became ionized when it's exposed to radiation from a radiographic exposure and electronic charge is created. Minimum response time is the shortest time of the exposure that the system can generate. The minimum response time is often longer with an AEC system than with other classification radiographic timers. With a modern AEC system, it's usually 1 millisecond. It can be a problem with patients who cannot hold still, or they are pediatrics, they're not following instructions. Also, the condition of the patient as Parkinson is complicated, so you need to, as a technologist, try to decrease the timing of your exposure. Often, the radiographer increases the MA to terminate the exposure time in a quicker manner. Minimum response time is the shortest time of exposure that the system can generate. The minimum response time is often longer with AEC system than with other classification of radiographic timers. One of the implications of minimum response time is more than the time required to end the projected exposure. There will be an increased amount of radiation getting into the image receptor. Often, the radiographer increases the MA to terminate the exposure time in a quicker manner. It can be a problem with patients who cannot hold still, as uncooperative patients, pediatrics, or a person with a condition as a Parkinson's disease. The AEC is not the device to use in these situations. Backup time is the maximum time straight the X-ray exposure will proceed when operating an AE system. The backup time can be set by the radiographer or facilitated mechanically by the radiographic unit. It may be placed as a backup MAS or backup exposure time, product of exposure time, or MA. The backup time plays a role as a safety measure when an AAC system fell off if a device is not used properly. Density control adjustments. AEC systems are engaged with density control that facilitates the adjustment of the amount of projected radiation by the radiographer. Usually, they are in the form of buttons of the control panel, and they are labeled as -2, -1, 0, +1, and +2, and so on. The real numbers placed on the density control vary. All the numbers change the time of the exposure by projected the amount of rise that will express as a percentage. Alignment and position consideration, compensation issues, and collimation. The selection of the detectors to use for a certain exam is significant when we are using an AE system. AE system with a lot of detectors somehow allow the radiographer to choose a combination of 1, 2 or more detectors. The selected tube detectors reliability measure radiation during exposure, and the electrical signal are regulated. Often the detector that takes the greatest amount of exposure has more impact on the total exposure. I would like to show you an example or a density control where we have us console buttons right here. There are -2, -1, 0, +1, and +2. So if we have an underexposure image, we need to increase the density. So if we increase those densities, they will give us a better image. But how we want to do this? Then we have to calculate how much density we require on this image. We say the first exposure, it looks like this, and then if we increase to +1, they will increase 25% of density on this image, creating an optimal image. If we have to increase the density into +2, it will be 50%. And here we have a number 3, there will be 75%. And if we have a 4, it will be 100%. But we choose the increase of density accordingly to the patient thickness, the body part, and how the underexposed image was looking. So that's the good thing about density control, who allow us to modify those MAS to get the proper image. I want to show you an image of the control panel who control the X-ray tube and how the AC control it looks like. They have 3 different chambers, and they have 7 possible configurations. So you can choose 1 and 2, 1 and 3, or the 3 of them, and you can combine it in 7 different ways. It's very important to select the proper chamber and choose the proper combination of it, because if you left a chamber without the body part, can prematurely set off the alarm, and it will be necessary to expose the patient again.